Hi everyone. In this video, we will learn about a concept which is very important to understand the structure of bases. As you know that the bases may exist even in a different form. Bases like adenine, guanine, cytosine, and thymine they may exist in two different forms by a process that is called tautomerism. So what happens during this tautomerism? So this tautomerism is opposite to the other concept which is very famous in chemistry, that is called resonance. So in resonance, the electrons they delocalize between the atoms in a molecule. So this resonance is possible when a molecule is made up of more than two atoms, and when only two atoms are present, that is in a diatomic molecule, the resonance is not possible as the electrons don't have any way to move from one atom to the other atom, because the electrons must be present between only two atoms. Whereas when a molecule is consist of more than two atoms, so the shifting of electrons is possible between the atoms, so that the atoms can form new bonds between them, or we can say we can bonds shifting between the atoms. Still the structure of that molecule doesn't change. So the chemical properties of that molecule doesn't change, only the physical properties of that molecule changes. So that's why this is called a physical phenomenon. So similarly, bases, so there we see um, uh, a different aspect that is called resonance, that is called tautomerism. So which is completely opposite to the process of resonance. In tautomerism, we see the movement of the atoms from in a molecule. We see the movement of atoms from one position to the other position. So due to this, we see a completely a different structure, or a different compound, formation of a different compound. For example, adenine, which has a functional group of amino group at sixth carbon. So the sixth carbon is attached to a functional group that is called amino group. So when a proton from this amino group moves or transferred to the first nitrogenous group, what happens, see, this becomes this amino form becomes into amino form. So the amino form changes into amino form by movement of a proton from this amino functional group to the other nitrogen atom present in this particular purine. Okay. Similarly, in a guanine, where you can see that there at the sixth position it has oxo group. So from this first nitrogen atom in this guanine, when a proton shifts from here to the oxo group, so that becomes into enol, a functional group. So this is called again a tautomerism. So what happens because of this, that no, the amino group which forms hydrogen bond, when it becomes into imino form, so that imino form cannot form a hydrogen bond. Similarly, because that no, this amino group acts as uh, a donor for hydrogen bond. Similarly, in a guanine, where oxo group acts as an acceptor for this hydrogen bond, when hydrogen, that is when that proton moves from this nitrogen to this oxo group and makes it into turns this into enol form. So this oxo group cannot be it cannot be a receiver. So it cannot be acceptor, so that it cannot form the hydrogen bond. So the regular hydrogen bonds formation between the bases becomes difficult. Similarly, when we see the cytosine, so in the cytosine also, where we see the delocalization of this proton from the amino functional group, which is on the top side, that is and the fourth carbon atom, the amino group, is present in the cytosine. So in the cytosine, where we see the movement, the delocalization of this proton to the third atom of this pyrimidine ring, that is nitrogen. So due to this also, that amino group cannot form the that cannot form hydrogen bond, regular hydrogen bond. So during so with it's a complementary strand. Okay, so in the thymine also, where we know that three functional groups, two oxo groups and one amino group, sorry, one methyl group are present, and amino group is absent here. So here also we see the turning of this oxo group, that is a keto group, into the enol form, where the proton from that a third from the third nitrogen atom shifts to the this oxo group and makes this into the enol group. So this tautomerism is a completely oppository resonance. So in resonance, we observe the shifting of electrons between the atoms in a molecule, whereas whereas in this tautomerism, we see the shifting of the atoms within the molecules. Okay, so this shifting of molecule makes or it affects the regular hydrogen bonds formation between bases in a complementary strands. Thank you so much.